We'll start the class. As I told you, the topic name is probability, right? Yes. What is probability? So before starting with the probability concept, let us first recall all the basics required for this topic, starting from permutation and combination. So without knowing permutation and combination, we may not be getting complete score in probability, because there are a lot of concepts which are having basics of permutation and combination, right? So while understanding permutation combination, we learned one basic principle, that is fundamental principle of counting. Do you remember fundamental principle of counting? Okay. So what is this fundamental principle of counting? So let me give a simple example. Okay. So what is, let us assume you're going to a shopping mall nearby, so which has say 3 doors to enter, 3 glass doors to enter, door 1, G1, G2, G3, and 2 wooden doors to exit, that is W1 and W2. So now you are being given a task to enter this mall. How many different ways you can enter this mall? So there are how many ways you can enter to the first mall, or the second mall, or the third mall. So how many ways? 3 ways. And you have to exit now. How many ways you can exit is 1 plus 1. That is either the first door or the second door. That's going to be how many ways? 2 ways. Now I want you to do both. You have to enter and exit. So how this person can enter and exit? How many different ways? So that means if he is given a chance to enter and exit, again enter in a different way and exit in a different way, how many different combinations are possible? That's what this question is all about. So he can enter through 3 ways, he can exit through 2 ways, but if he has to enter and exit, for this entry, there are 2 ways of exit, right? I can write G1, W1, G1, W2. Now for this second door of entry, there are again 2 ways of exit, that is G2, W1, G2, W2. And the third, again, he can enter through third end door and exit in 2 different ways, G3, W1, G3, W2. So totally, if I add all of them, how many ways I have? 6 ways. Right? Instead of adding like this, I can simply multiply these two and say 6 ways. In general, if you have say m ways to enter and n ways to exit, total number of ways of entering and exit is how many ways? M into n ways. Okay. So the fundamental principle of counting says if a task can be done in m different ways and another task can be done in n different ways. Okay. So if you want to do both the tasks together, the number of ways it takes is m into n ways. Okay. Suppose if you want to do only one of them, either of them, only each of them, that becomes m plus n ways. Simple way to understand is wherever and is there, you're going to multiply. Wherever r is there, you're going to add. Okay. So that is fundamental principle of counting. Any questions in this? This we have learned in 11th standard itself, right? Yes. So that means if a task A can be done in m ways and task B can be done in n ways and another task C can be done in p ways. If only one of them has to be done, either A or B or C, then how many ways it can be? M plus n plus p ways. But if all of them has to be done, A and B and C, all of them have to be done, then it is m into n into p ways. So we multiply in the case of and we add in the place of or. That is what fundamental principle of counting says. Okay. So is that clear? Yes. Now let's have a quick look at the concept of permutation. Okay, and combination. Even though we're not going to see in detail, we learned this in detail in the 11th standard itself, right? So what is permutation? Permutation is an activity, okay, which involve two tasks, just like entering a mall and exiting a mall. This has two tasks. One task is selection and another task is arrangement. Okay. So what about combination? Combination is only one task, that is selection. So what I can observe is selection is already a part of permutation. That means combination is already a part of permutation. Remember that. Okay. Without arrangement, if it remains only selection, it becomes combination. So what is the selection and arrangement? Let me give an example. Assume there is a classroom, okay, which has four chairs, okay, and outside the classroom there are 10 students waiting outside the classroom. Now there are four chairs. How many ways I can seat these 10 students in the four chairs? So obviously, practically speaking, only one person can sit in a chair. That means all the 10 students cannot be accommodated in the four chairs together. First, I have to select who is going to sit first. I have to select who is going to sit. Once you select, I'm going to arrange them. Okay. So let us observe analytically. If I say first chair, there are 10 different students. Anyone can sit. So 10 different ways. And because we have to do this as well as the next chair. So and in the place of and we have to do multiplication, right? In the second chair, as I cannot seat the same student in the second chair, it is 10 minus 1, 9. Then we have 8, then we have 7. So that is 10 into 9 into 8 into 7. So here the number of chairs is represented by letter R and number of students are represented by letter P. Selecting and arranging, selecting and arranging, so letter N, okay. Selecting and arranging N objects in the R places is given by NPR. So here it can also be written as 10P4 now, which can be seen as 10 into 10 minus 1 into 10 minus 2 into 10 minus 3. Okay. So if there are four chairs, we are going to stop at fourth chair, but the fourth chair will go with n minus r. This is one less, right? Why? Because we start with 10 minus 0. So in general, if I want to expand NPR, it is n into n minus 1, n minus 2. It won't go till the end. It will stop at n minus r minus 1. Okay. So that means if I want to see 20 students in 10 chairs, it will stop at what point? 20 minus 9. That is 20 minus 10 minus 1, which is 20 minus 9. What is it? 11. This 11 will be 10th chair. Okay. If it is 20p, if it is 30p, 15, I should know I should stop at 30, 29 till 30 minus 15 minus 1, which is 30 minus 14, 16. So to make it more simple, let us make it very easy. So if I have to take an example, let me take another example. Instead of 10 chairs for students, what we can do is, let me erase this. Yes. So what if the numbers are bigger? I cannot expand like this, right? At least I need to make it look simple. So what I'm going to do here is, if it is 100 students and 40 chairs, so I can go till what number? 199 minus 100 minus 39, 61, right? Further, I'm going to multiply and divide by something to make it simple. So what is that something? I'll show you. I'll multiply the numerator and denominator by 60, 59 till what? Till 1. So again, multiply and denominator, yeah, or multiply and divide by the same number so that answer is not altered. So if that is the case, what is the numerator simply written as? So if we can simply simplify this expression, you can write it as 100p40 as 100 factorial by 40 factorial. Okay. Further, in the question, I don't have 40. I have only 100 as well as 60. So I can write it as 100 minus 60 factorial. So what is in general then? What is 60 here? 100 minus, this is 60 factorial. So it's 100 minus 40 factorial. So what is 40 here? R. What is 100 here? N. So NPR is nothing but what? N factorial by N minus R factorial. So this is how we got the formula for permutation. Okay, that's the formula for permutation. Getting it? Yes. Let me quickly erase all these things. Then I told you permutation is nothing but a task which has both selection and what is it? Arrangement. So if it has selection as well as arrangement and combination is nothing but selection, I can say selection is nothing but a part of the permutation or combination is a part of the permutation. So now let me understand what is arrangement meaning now. So if the number of chairs is equal to number of objects, say 5 students and 5 chairs. I have only 5 students and 5 chairs. Now I don't have to select anybody because all of them are supposed to be sitting here. So this involves only what? Arrangement. If the number of chairs is equal to number of students, it will be directly arrangement. That is first chair 5 ways, second chair 4, 3, 2, 1, which is 5 factorial, which can also be written as 5p5. Okay, that means if n is equal to r, that task is nothing but arrangement only, and that can be simply written as r factorial. Remember this. That means the permutation I can write as npr. Selection is combination. I write it as ncr. ncr means selecting r out of n, and in the place of and I should write arrangement, multiplication, and in the place of arrangement I should write r factorial. Now by simplifying ncr, it is npr by r factorial. Very easy to understand. If you want to write it in n factorial format, npr is n factorial by n minus r factorial, again divide by r factorial. So now whichever is the way convenient for you, you can use it. But this is how we can remember the formula for combination as well as permutation. And also very important observation is npn is nothing but in this case n factorial. By using the formula, it becomes n factorial by 0 factorial, which indicates 0 factorial is equal to what? 1. Right? Yes. The value of 0 factorial is equal to 1. So please make a note of all these things because you might have forgotten what you learned in the 11th standard. So I want you to make a note of this for your reference. Okay, otherwise there will be a lot of confusion while solving the questions in probability. Fine? Yes. Now remember these values which are very important. 0 factorial is 1. 1 factorial is also 1. What is 2 factorial? 2. 3 factorial 6. 4 factorial 24. 5 factorial, what is it? 120. 6 factorial 720. 7 factorial 5040. Okay. 8 factorial, what is this? 40. How much is 8 factorial? Can anyone tell me? Multiply the given number, the given previous number, into 8. So what do we get? 400320. Okay, so it's easy to remember them so that you can directly add the values whenever it's needed. Okay, so and remember npn is equal to n factorial. That is also equal to np n minus 1. Same example, I'll take 5p5 is actually 5 into 4 into 3 into 2 into 1, which is actually 5 factorial. What about 5p4? What is going to be reduced? Only the last number, which is 1, has been removed. Will it change any value? No. That is why npn is equal to NP n minus 1. Okay. What about NP1 now? Only one chair, n students, that is n ways. Okay. Are you understanding? Yes. Coming to combination, what is NC1? Okay. So NC1 is actually n. And remember this shortcut, this is very, very frequently used shortcut. NCR is equal to NC n minus R. Okay, that's why NC1 is equal to NC n minus 1. Both are equal to n. And what is NC0? Selecting nobody, doing nothing, and selecting everybody. Both are equal to 1. Right? Selecting nobody and selecting everybody is also equal to 1. So yes, all this is the formula which we have to remember and recall. We have to use it in probability class, today's class as well. Okay. Any questions so far? Any doubts? No doubts, right? Yes. So let me take an example to make it, as we are familiar with the concept now. So let me take an example. How many ways can letters of the word great can be arranged? This is an example. Without repetition, that is, there are 5-letter word. Without repetition, it is 5 into 4 into 3 into 2 into 1, which is simply 5p5 or 5 factorial. With repetition, if I ask you, that is 5 into 5 into 5 into 5 into 5, which is 5 power 5. So remember, any task, if n places, r places, n objects, you want to arrange without repetition, which can be written as what? NPR. Now, with the repetition, what will happen is it will become n power r. Okay, if you can repeat more than one time, that is with repetition, so it is n power r. Remember? Yes. So again, make a note of this. A task can be done without repetition, that becomes permutation. With repetition, that becomes n power r. Here P stands for permutation. Why do we use the letter P? It stands for permutation. Okay? Yes. So another example, from a group of say 8 boys and 6 girls, a team has to be formed. A team has to be formed of say 5 students. Okay, so one condition is it has to have 4 boys and 1 girl. How many ways you can do that? So you can only choose 4 boys from boys, right? That is 8C4 and then 6C1. So you got 8C4 and 6C1. What is 8C4? 8C4 is going to be 8 into 7 into 6 into 5 divided by 4 factorial, which is 24. This is how I'm using the factorial values. 6 as it is. 6 ones are 6 fours are 4 ones are 4 twos are. So which is 420 ways. Okay, you should be fast in multiplication. So next, if I say another condition, which should have at least 3 boys. What will be at least 3 boys? It can have 3 boys from the 8 boys, and then I can have remaining 2 girls, or I can have 4 boys and 1 girl, or I can have all the 5 boys, no girl. So all these expansions, if you try, you'll get the answer. Okay, I don't want to get into detail of all this right now because we have learned these things in our 11th standard itself. So it was just a quick recap. Okay, any questions so far in these things? No questions, right? Yeah. So now let's start with the today's concept, that is probability. So what is probability? Hmm? So before understanding probability, we need to know something called experiment. What is an experiment? Any process in our day-to-day life which gives some result at the end of the process is called experiment. And based on the results, we classify the experiment into two types. One is scientific experiment and another one is random experiment. Okay, scientific experiment as well as random experiment. So based on the result only. So can you now tell me what is the main difference between the random experiment and scientific experiment? A scientific experiment is an experiment which will give you the same result if the particular conditions are maintained. For example, if you're conducting a chemistry experiment, if the temperature, pressure, everything is maintained, you will know surely what is the result. Okay, because they follow the rules like that. So that means in scientific experiment, the outcome is always clearly understood. We can even estimate the exact output, okay, or the result. But as random experiment is a one which keeps changing and we won't be able to tell the exact outcome. So that even if you maintain the same temperature, pressure, everything, if you maintain the physical conditions are maintained, but still you won't be getting the same output or result. Such an experiment is called random experiment. Simple example for random experiment is tossing a coin. Okay, tossing a coin. When you toss a coin, what are the results? What are the possible results? I cannot tell exactly what is going to happen, but possibly what is the result? Either head or a tail, right? The result of a random experiment is called what? Outcome. So what is the outcome of tossing a coin? Head or a tail? Okay. Yes. Similarly, any other example? Throwing a die. When you throw a die, what are the outcomes we have? We get either 1 or 2 or 3 or 4 or 5 or 6. That is a set of all possible outcomes. Okay, so when you toss a coin, we have head and then tail. That is set of all possible outcomes. Okay, so like this, every experiment, every random experiment, I can discuss and tell the possible outcomes. Okay, so those outcomes, if you write it in the set, that kind of set is called sample space. You can make a note of it, which is represented by letter S. What is sample space? Set of all possible outcomes of an event. Okay. Now, what is an event? What is an event? An event is is a way of expecting a particular result or outcome. Okay, so conducting an experiment. When you conduct an experiment, if you are expecting a particular set of outcome, that becomes an event. Okay, so based on all these things, we can define the definition of a probability. Let's see what is the definition of a probability. Just let me take a moment. Let me stop presenting. The basics of probability and the basic definitions we need to remember and understand. Not just by hearting the or memorizing these definitions will help us. We need to know the meaning of it because probability is such a concept where by only memorizing the formula, you won't be able to solve even a single question. Okay, so only if you know the reality in the real life, how these situations work, and accordingly you have to answer the questions, right? That's what probability is all about. That is the beauty about this topic. It is not like integration or differentiation where you know the formula and differentiate, integrate just like that. So you need to understand situation very well. In the real life, you have to imagine how it works, and then you have to take the decisions here. Okay, so I'll tell you what I exactly mean by these statements. So now probability in mathematical field of probability, likelihood of an event occurring is predicted by assigning a numerical number to the possibilities of it happening. Okay, so that's what they say. And we discussed random experiment. Let me recall all this again. Random experiments are those in which, despite being carried out under the same conditions, as I mentioned, the result could differ. For example, what is it saying? Yes. For example, tossing a coin, a random experiment, since the result could be head or a tail. Okay. Trial. What is a trial? Trial is an act of carrying out an event. What is an event? A trial's potential results are referred to as event. For example, getting a head, that is denoted by P of H. That is an event. Okay. A trial is tossing a coin, whereas getting a head is an event. Okay. So events can be classified into different types. So let's discuss that. Okay. First, what is probability of an event? That is a ratio. It's a real number. That's a ratio of number of, what is it? Favorable outcomes. What is outcomes? Number results, right? Divided by total number of outcomes, right? That is probability. Am I right? Yes. So probability always lies between 0 and 1. The highest value probability can take is 1, because if you expect everything from the total number of outcomes, the numerator and denominator becomes same. That's why it becomes 1. Or else it will be anything less than 1, but it is always positive. So it can be even 0 also, but it will never become negative. Okay, because it's just a number, and these numbers are positive numbers, right? Right. It can be 0 also, but it cannot become negative. Okay. So, and based on the types of event on different categories, in different basis, we can classify the events. Here, there are two types they are given. One is simple event and a compound event. What is simple event? An elementary or a sample event uh, is one that consists of uh, just one sample point. So what is the sample point? I said sample space, right? Sample space is having multiple outcomes, right? All the outcomes, set of all the outcomes. That is sample space. This is a sample space for what? Tossing and throwing a die. If I take only one outcome and that is converted to a probability, an event, that kind of event is called simple event. For example, getting a one, which is equal to getting a 2. I'll come to all that. What is getting 1 in a die? Totally, how many outcomes are there? 6. And I need to get one outcome, and that one outcome is 1. Number of outcome is 1. So it becomes a simple event. Getting a head is a simple event. There are total outcomes 2, in that I am expecting one of them, that is 1 by 2. That is simple event. What is compound event? A compound events are those that result from merging two or more elementary events. For example, getting an even number. So getting an even number means which has three simple events, right? Getting 1, so getting 2, getting 4, and getting 6. So if you add getting 4, getting 2 is 1 by 2, right? And getting uh, 4 is also 1 by 2. Getting 6 is also 1 by 2. 1 by 6, right? 1 by 6, 1 by 6, and 1 by 6. When you add all of them, what happens is denominator is 6, denominator is 3, it becomes 1 by 2. It's a combination of more than one simple event. Such an event is called compound event. Look at this example. Hmm. For instance, an event of receiving a doublet on a single throw of a pair of dice is a compound event since it can occur at any of the elementary events. For example, getting a doublet. What do you mean by doublet? Getting a doublet means repeating the same number. So I can have 1 comma 1 and 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5, as well as 6 comma 6. So that is doublet. So totally how many outcomes are there is we will have 36 outcomes. In that having a doublet is 6 outcomes. This is actually 1 by 6 and this is a compound event because it has multiple single events merged together or simple events merged together to get this compound event. Okay, that's why it's called compound event. Okay, let's see further definitions. Events that are equally likely. What do you mean by equally likely? As the name itself says, if the chances of two or more events are equal to each other, such events are called equally likely events. What do you mean by that? What is the probability of getting a head? Just we discussed 1 by 2. What is the probability of getting a tail? That is also 1 by 2 in the same toss. So in this case, probability of head is equal to probability of tail. So that is because they are equally likely. So it doesn't mean that it has to be 1 by 2 only. What about probability of getting a 1 in a die? Is also equal to 2 in a die. Is also equal to 3 in a die. Is also equal to 4. It is also equal to probability of 5. This is also equal to probability of 6. All these are equal to what? 1 by 6. So this is what kind of event? These are equally likely events. Okay. So next what we have is mutually exclusive event. The name, you need to know these definitions by the name itself. Mutually exclusive event. Another way to say them is disjoint event. Mutually exclusive. Exclusive means what? Okay, so they will not happen together. So, for example, two or more events are said to be mutually exclusive or disjoint if they do not occur together. For example, occurrence of one event excludes the occurrence or chance of another event. Simple example is when you're throwing a die, if you get a head, is it possible to get a tail? No, right? So getting a head as well as getting a tail are mutually exclusive to each other. They will never occur together. So one of them, occurrence of one event stops the occurrence of the other. In case of a die, getting an even number, getting an odd number, will they occur together again? They will never occur, right? Such events are called mutually exclusive event. Okay, so usually mutually exclusive events are either binary in mostly binary in nature. It is not a condition. You might have more than two possibilities also. Okay, so they will never occur together. Okay, as they don't occur together, two such events intersection is always equal to 0 or a null set. Okay, so that will be never possible at all. Next, events that are not mutually exclusive. The events that do not conflict with one another are referred to as compatible events or non-mutually exclusive events. Okay. So what is independent event? As the name itself says, if two events does not have any connection at all, there is no way they can affect each other. Such events are called independent events. When one event happening is unaffected is by the happening of the other event. They are called independent event. Now, can you tell me mutually exclusive event? Are they independent or dependent? Can you tell me mutually exclusive event? Are they independent or dependent? Anybody? Can anyone answer that question? Mutually exclusive events are dependent event. Why? They are 100% dependent. Why? Because occurrence of one of the event depends upon the occurrence of the other event. So they are 100% dependent events. They are not independent events. Okay. So Now, example for independent event is if two dice are thrown together, the likelihood of getting a particular number in one die and same number in another die are actually 100% what? See here. For instance, two dice are thrown together, the likelihood of having an odd number or an even number in the second die does not affect or does not depend upon the type of outcome we get in the first die. Such events are called mutually exclusive, and such events are called independent events, right? Yes. Let's get back to this. We need to know all these definitions and the concepts so that we can be thorough with the concept and we can understand the question correctly. So that's very, very important in a chapter like probability. Okay, let's see. Dependent events. So dependent events, that's what very important for us today's class, because in dependent events, we have a particular concept in our 12th standard which mainly focuses on the dependent event. So in our 11th standard, we only discussed mostly independent events, right? Dependent event, when one event occurs and influences another, such events are called dependent events. So two or more occurrences are said to be reliant on each other. Let's say a bag contains four black balls and five white balls. One by one, two balls are drawn. If the first ball is replaced before drawing the second ball, then the two events, that is, the first ball is white and the second ball being black, are independent. Whereas these two occurrences will be reliant on each other if the first ball is not changed, as there will be only 8 exclusive situations in the second draw. For example, let me take the same example here. See, there are a bag contains four black balls, and then five white balls. Now, you are going to choose two balls, one after the other. Two balls, one after the other. So, choosing, what is our question now is the probability of getting uh, first ball is white and the second ball is black. So first ball is white and second ball is black. So if you're choosing first ball white, so how many balls are there? 4 by 9. Now if you don't replace, if you replace that again, then I can definitely say the next possibility is 5 by 9. So it doesn't affect. Whereas if you replace, if you replace it, if you don't replace it, what happens? First one is 4 by 9, second one becomes 4 by 8 because one ball reduced, another ball is also, the total number of balls is also reduced. So that is 5 by 8, sorry, because the number of black balls are still 5 only. Okay, but the total number of balls became 8. So they depend upon each other. The result depend upon each other. Such events are called dependent events. It depends. Okay. Then we understood mutually exclusive. There's very, very important definition, that is collectively exhaustive. What do you mean by collectively exhaustive? Exhaust. What do you mean by the word exhaust? Exhaust means finished, right? When you exhaust all the possibilities, okay, when you take a set of event or a combination of an event, that particular event exhausts all the outcomes. Such an event is called collectively exhaustive. Okay, for example, getting a head or a tail. What is left in the toss then? Nothing is left, everything else is taken, right? Such events are called collectively exhaustive. So getting a head is one event, getting a tail is another event. So when you take these two together, that becomes collectively exhaustive. Okay, getting an odd number in a die, getting an even number in a die. Okay, similarly, there are many other examples. Maybe getting a one, it need not be always two. Okay, it need not be always binary. That's what I'm saying. Getting one, getting primary number, and getting a composite number in a die. So they are also collectively exhaustive. Okay, why they're collectively exhaustive even though there are three? Because there's nothing else left after that, right? So this is not binary in nature. So we have three different combinations. When you put them all of them together, that becomes collectively exhaustive. So it is very, very important to understand whether the given events are mutually exclusive and collectively exhaustive or not. Because if I say if E1 and E2 are two events which are mutually exclusive as well as collectively exhaustive, then I can definitely say sum of their probabilities, sum of their probabilities will be equal to 1. Remember, so this will be 100% correct only when they're mutually exclusive as well as correctly exhaustive. I can use this as a shortcut such a way that if I want to find P of E1 and if I can easily find out P of E2 provided they're mutually exclusive, then I can subtract this from 1 instead of finding P of E1. Okay, if it is a time consuming process, you can do the opposite. So this shortcut we're going to use in many places. So remember, this we can do only if you know they are mutually exclusive and collectively exhaustive. Right? Yes. Now, another definition you need to know is, as I told you, probability of an event lies between which values? 0 and 1. If probability of an event is 0, that's called impossible event. So can you give me an example for impossible event? Now you cannot say nothing is impossible. Okay. So there are many things impossible in this world. So one, I can say when you throw a die, can you get 7? Obviously it's impossible, right? That's an impossible event. When you toss a coin, can you get both head and tail together? No, that is impossible event. Can you score 150 out of 100 marks? Impossible, right? So let's not be philosophically saying everything is possible. So here we're just understanding in practical life, there are many things which are impossible. When we look at their chances, that become 0. Such events are called impossible event. Okay. So then what if the probability of an event is exactly equal to 1? It's called sure event. It is not called possible event. Anything from 0 to 1 is possible event. But if it is exactly 1, it's called sure event, 100% chance. Okay, that's definitely going to happen. Okay, example, getting either head or a tail. Definitely it will happen, right? When you toss a coin, definitely one of them will come. Sure event is also sometimes called certain event. Certainly it's going to happen. Okay, certain, we are so certain that this is going to happen. Such events are called certain events. Example again, getting either an odd number or an even number in a tie. Definitely one of them should come, no? Right? Yes. Right? So any other example for impossible event? Having 8 days in a week. Do you have any week which is having 8 days? No. Having 32 days in a month. So no month has 32 days, right? So I can keep on saying all the impossibilities in this world, right? So we can have infinite events which are impossible, right? So similarly, we have infinite events which can be 100% sure event also. Okay, let's now get into the actual part of this class. This is all basics that we learned in the 12th standard, 11th standard itself, right? Yes. So enough of basics, right? There is a keynote here. Can you please read this? So mutually exclusive events are taken from a single experiment, whereas independent events are always taken from a separate experiment. Just some points to remember. Events that are mutually exclusive cannot occur concurrently. although independent events can. Okay. So the term and links the independent event, but the term word or links the mutually exclusive occurrences. Just remember those things, not to take it taken seriously for now. So we are just understanding the basics yet. Okay. Yes. So as I told you, the definition of probability is given here. What is the probability that an event will occur, which is represented by P of E symbolically? The chance that an event A will occur is given by a random experiment yield n mutually exclusive, equally likely, and exhaustive alternatives of which m are favorable to occurrence of the event A. So we don't have to worry about this part right now. So I'll just tell you this particular definition symbolically. Probability of an event is given by number of favorable outcomes divided by number of total number of outcomes. So here this is first and sample space. Okay. So total number of, for example, tossing a coin, number of outcomes totally two, and I need head, so one by two. Okay, so getting a 1 out of 6 outcomes in a die, a 2 is also one event only. I'm not going to write 2 here. 2 is number of events, 1, right? So 3 is also 1, one particular outcome, right? These are the values. Okay. So then what is the probability of a sample space? Can anyone tell me? Probability of a sample space. What do you mean by sample space? Set of all possible outcomes. Denominator is all the outcomes, total outcomes. Numerator also total outcomes. Then what will happen is it will become 1. So probability of a sample space is always equal to 1. Not to confuse this with a sure event. This is asking everything that can happen in an event. That's why the numerator is equal to denominator. So it becomes 1. Okay. This might be asked in the multiple choice questions. All the definitions and the related terminologies and the connections, whatever we learned right now, that can be asked in the multiple choice questions. Okay. For an occurrence of a to be certain, its greatest probability is what? 1. The likelihood of any given occurrence E must be either greater than or equal to 0 and less than or equal to 1. That's called range of the probability. So range of the probability. Fine. Any questions now so far? Any doubts? Okay. So can you please read these statements once? It is obvious that if m is less than or equal to n and both of them are more than 0, in event x is certain to happen, then m is equal to n, thus p of x is equal to 1. So if x is impossible to happen, okay, then m is equal to 0, so p of x is 0. Hence we can conclude that probability always lies between 0 to 1. Further, x bar denotes non-occurrence. So if the probability of x is p of x, probability of non-occurrence is p of x bar. So and they are completely mutually exclusive as well as collectively exhaustive. That's why their product sum will be equal to 1. That means I can say probability of x bar, that is complement of an event, is equal to 1 minus p of x. So we can even write a dash, which is p of 1 minus p of a. So such events are called complementary event. Okay, complement of an event. Okay, yes. So all this we have learned in our 12th standard. Okay, now coin we understood already. If you throw one coin, the total number of outcome is 2. If you throw, what are the outcomes? Sample spaces, head and tail. If you throw 2 coins, how many outcomes are possible? Can anyone tell me? 4 outcomes. What are the outcomes? Head, 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 tail, tail, head, tail, tail. How many outcomes are there? 4 outcomes. Can anyone tell me the 3 coins are tossed? How many outcomes are possible? All are head? Yes. And then 1 head, 1 tail, 2 heads. This can happen how many ways, you know? 3 ways. You want me to write all the 3 ways? Yes, I can write head, tail, head, tail, head, head. Now, two tails, one head. This can also happen how many ways? Three ways. I'll write that as well. Tail, tail, head, tail, and head, tail, tail. Last one, all are tails. That can also happen only one way. Now, can you count how many ways we have? 8 ways. So this I cannot keep on writing, but what can I say is, as there are two outcomes for every toss, and if you have n tosses, total number of outcomes is going to be 2 per n outcomes. So whenever you toss a coin, your denominator is fixed as 2 per n. Remember that, because the denominator is always equal to what? Total number of outcomes. Similarly, if you throw a die, there are 6 outcomes, right? But if you throw two dice, it is 6 into 6, 36 outcomes. In general, n throws will give you 6 power n outcomes. That's for a coin. That's for a die. Okay. That's what is mentioned here. You can read them. Cubical die has 6 faces, which are labeled 1, 2, 3, 4, 5, and 6. We might experience a pentagonal or tetrahedral. Okay, with faces 1, 2, 3, 4, 5, a tetrahedral with 4 faces 1, 2, 3, 4. Okay, if there are multiple dice, they are all regarded as a unique until otherwise indicated, just like with the coins. Then the number of complete instances where n dice are thrown at once or throwing one dice n number of times is given by 6 power n. Whether you throw n dice together or one dice n times, total number of outcomes is going to be 6 power n. Same way, if you throw n coins together or one coin n number of times, your denominator is total number of outcomes, which is 2 power n. Okay. Yes. Now we need to know a very basic understanding of cards as well. Okay. Playing cards. So in a pack, in a deck, okay, how many cards are there? In a deck, I'll be having how many cards? 52 cards. You don't have to learn to play cards. You need to know the logic behind these cards. Okay. So there's no need to play and learn these cards right now. We just have to know what type of cards, what are the names we use. Okay. So out of the 52 cards, we can classify them into two colors. That is, we have 26 red cards and 26 black cards, generally black and red, right? In the red cards, we know 13 hearts. Okay, this is the shape, 13 hearts, and 13 diamonds are there. Am I right? And similarly, in the black cards, we have 13 clubs. Okay, 13 clubs, and what we have? 13 spades, right? So these are 13 cards. Out of these 13 cards, there is one king in all of the uh, shades, right? All of the suits, we call them as suits. King, queen, jack, and ace. Okay. So in all of the 13 cards, we'll be having one king, one queen, one jack, and one ace. After that, we'll have a numbered cards 2, 3, 4 till 10. Right? Can you tell me totally how many numbered cards are there in each of the suit? 9 cards, right? So that means the remaining 4 cards, there is a name for them. They are called face cards, or generally we call them as honor cards. Okay. So that means I can further classify these 52 cards as honor cards as well as numbered cards. So how many numbered cards are there? 9 into 4, 36 numbered cards, and then 16 honor cards. So all these are important for us to solve the questions. Okay. And what you should know is there is no red spade or black heart, black diamond, or red club. They are not possible, right? Yes. So face cards, there is a small correction here. Face cards are only kings, queens, and jacks. We call them as the face cards. Okay. But together, if you use A's also, that becomes honor card. So small difference. A face card include king, queen, and jack only, whereas honor card includes king, queen, jack, as well as ace. So be clear about those names or terms. Fine. Any questions so far? Any doubts? No doubts. Okay. Yes. Another important logic we need to know. Uh, Probability of n letters and their matching envelopes is as follows. If n letters randomly corresponds to n envelope and are placed in envelope, then the likelihood that every letter is in the proper envelope 1 by n factorial. Okay, so chance that not every letter in the proper envelope is 1 minus 1 by n factorial. So that is called, there is another name for this kind of uh, process. It's called derangement. Just like we know arrangements, we have a formula for derangements. So what is this derangement? I'll tell you. So this is a formula for derangements. For example, if there are three letters and three envelopes, how many ways? So letter 1, letter 2, letter 3, envelope 1, envelope 2, envelope 3. Now my question is how many different ways you can arrange these letters in envelope in such a way that no letter goes to the right envelope. For example, if I want to use this L, this has to go to E or E2 or E3. Okay. Whereas L2 has to go to either E1 or E3 only, not E2. Similarly, L3 should not go to E3, it should go to E1 and E2. That's called derangement. So according to this formula, the likelihood that R letters are in the correct envelope is 1 by R factorial divided by 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial until 1 n minus 1 power n minus r into 1 by n minus r factorial. If I substitute r is equal to 2 now, what will happen is 1 by 2 factorial into what do we have is 1 by 2 factorial. So it will start with 1 by, what is our answer? 1 divided by, yeah. So let's, this has to be equal to 1 minus 1 by n factorial, right? So that is 1 minus 1 by 2 factorial. So what I should be getting here is 2 minus 1 by 2, which is 1 by 2. Okay, so it is directly the chance, right? So I should have got 1 by 2 itself. So out of the 6 chances, there are 3 chances where you can go for the different envelope. Okay, so let's use this formula directly when it is needed. So let's go to the next part of this class. Yeah, another important terminology we need to know is odds in favor and odds against. So what is odds in favor of an event? For that, you need to know the probability of an event. So odds in favor of an event is probability of occurrence of the event divided by probability of non-occurrence of the event. 1 minus P of E. Similarly, probability of odds against an event is, it's an inverse or reciprocal of odds in favor. That is probability of non-occurrence of the event divided by probability of occurrence of the event. Even though probability has a range, it is between 0 and 1. This odds in favor doesn't have a limit. It can be more than 1 also, it can be less than 1 also. but odds in favor is still a positive or zero. It cannot be negative. Okay, odds in favor or odds against can be more than one as well, possibly. It depends upon the probability of an event. Okay, so odds in favor, odds against are again reciprocal of each other. So if odds in favor is less than one, odds against can be more than one, and vice versa. And they can be equal to each other if their odds in favor are equal to each other. Okay, is equal to one, right? So that's possible only if they're equal to one, or else they're always, if one of them is more than one, another one will be less than one. So there is an important note. You can read that note as well here. If odds in favor of an event are A by B, okay, then the probability of the occurrence of that event is given by A by A plus B, and probability of non-occurrence of the event is B by A plus B. Suppose if you want to remember this, if you want to, don't memorize it, think about why this formula is coming like this. If odds in favor is A by B, then probability of an event is A by A plus B. Probability of non-occurrence of the event is B by A plus B. Okay. Similarly, odds against is given as A by B. Then definitely what will happen is probability of event is B by A plus B, and probability of non-occurrence of the event is A by A plus B. So if you can remember, good, or else try to please remember the formula and the condition. That is enough for us. We don't have to memorize unnecessary formula to confuse ourselves. But it is always good to know them and remember them only if you are good with the concept, not by memorizing them. Fine? Yes. Now, algebra probability. So what is algebra probability? Like how to operate probability expressions, right? So this is what it is. From the fundamental principle of counting, we have understood wherever R is there, we add. Wherever and is there, we multiply. But apart from this, there are some additional conditions here. If you're talking about probability of A or B, we can also use the symbol union. Okay, and can you recall in the sets what we do? N of A union B is equal to N of A plus N of B minus N of A intersection B. Same way, the probability of A or B or X or Y is given by probability of X plus probability of Y minus probability of X and Y. Right? So same as plus here and here product. Okay, so this stands for and, this stands for or. Remember this. Okay, and what is probability of X and Y? That is again very important. Probability of X intersection Y is probability of X into probability of Y for, very, very important, independent events only. For independent events only. What do you mean by this independent events only? So that means there is something different for dependent events. So that is the main crux of today's class. We are going to discuss how to deal with the dependent events. Okay, for independent events only, we use this formula. Probability of X and Y can be written as probability of X into probability of Y for only independent events. Okay. Similarly, we know for three sets, N of A union B union C is given by what? N of A plus N of B plus N of C minus N of A intersection B, N of B intersection C minus N of C intersection A plus N of A intersection B intersection C. Same way, probability can also be applied. X union Y union Z can be written as P of X plus P of Y plus P of Z minus P of X intersection Y minus P of Y intersection Z minus P of Z intersection X plus, because it becomes minus of minus, plus P of X, Y, Z. Okay, right. And remember, for if X and Y are mutually exclusive, then what will happen to this expression? This will become 0. For mutually exclusive, when P of X union Y will be directly P of X plus P of Y. Okay, since P of X intersection Y becomes 0, because they will never occur together if they are what? Mutually exclusive. I know this is too much of concepts, but we have not started the class yet. We are only recollecting what we learned in the 11th standard. Okay. Yes. So after all this has been clearly understood, we can move on to the actual concept for today's class in the 12th standard, what we learn here. Okay, so whatever I mentioned right now, it is given here. See, when the events are mutually exclusive, in the event that occurrence of A and B are mutually exclusive, then n of x intersection y will be 0. Then p of x intersection y is also 0. Then p of x union y will be what? P of x plus p of y. For any three events, they are mutually exclusive, then all this will become 0. Then p of x union y union z will be equal to directly p of x plus p of y plus p of z. Okay, so all this again. Yes, so now we will try to look at some solved examples. Okay, so please read the question first and try to understand the solution. We will discuss after that. I'll give you say 10, maybe 15 seconds. Please go through these solutions and the question as well. So tell me what is clear from this. So given that x and y are the events such that uh, it is not A, this is P. Okay, let's keep it as P. P of X, P of Y, probability, right? P of X by Y and P of Y by X. So what is it? Let's come to this later. Let's directly go to the solved examples now. Now we'll go to the first question in this. I'll take some more questions apart from this. From the set 1, 2, 3, 4, 5. So let's name it as A. 1, 2, 3, 4, 5. Two numbers are chosen such that A is not equal to B. So we are choosing two numbers and we should not choose same numbers. That is what it is saying. So at random. So probability that A by B is an integer. Can you imagine this correctly and try to give an answer? First, we have to choose what is our main condition. I am telling you, probability of an event can also be given as the possibilities without a condition, number of outcomes without a condition, and number of outcomes with a condition. There's another perspective of looking at the probability. So on that basis, our main condition is still the correct. So what is it? We are going to choose two numbers A and B. Okay, such that A is not equal to B. If A is not equal to B, how many ways you can choose them? Tell me. So A is not equal to B means I can choose 1, 2, 1, 3, 1, 4, 1, 5. Like this, you can choose, right? Instead of all this, what we can do, total number of ways is we cannot repeat the number. So it is 5 into 4, right? So again, coming back to our, what is it? Permutation combination. right? If you cannot repeat, it is 5 power 5p2. If you can repeat, it is 5 power 2. Now we cannot repeat, it is 5p2. How many ways 5p2? 5 into 4, 20 ways. Selecting any two numbers without repeating them because they are not equal is 20 ways. So total number of ways is 20 ways. And what is our numerator? The numerator cannot be understood directly because the condition says it has to be integer. This fraction has to be integer. So if you're choosing first number a comma b, a must be divisible by b so that it becomes integer. So how can you choose then? Can I choose 2 comma 1? Yes, because 2 by 1 is an integer. That means I can have 1 at the second place for all the numbers. Okay, 4 comma 1 and then 5 comma 1. Sir, why did I not take 1 comma 1? Can you tell me why? Think why I cannot take 1 comma 1. 1 by 1 is still integer, but why am I not taking 1 comma 1? Can anyone tell me why? Yes, we cannot take 1 comma 1 mainly because of the condition given a should never be equal to b. We should only take a different number. So these are the numbers. Anything else you can take is 4 comma 2 as well. So this is a favorable set of outcomes. Our favorable set of outcomes is this. But total number of outcomes, that is sample spaces, what are we having? So I cannot write all of them, but I can only tell that is going to having how many outcomes? 20 outcomes. You want me to write 20 outcomes? Yes, I can write it. I'll show you. So they will never repeat, right? For one alone, we'll be having how many numbers? 2, 1 comma 3, 1 comma 4, 1 comma 5. Similarly, 2 comma 1, 2 comma 2, 2 comma 3. So 2 comma 2 is not allowed. 2 comma 3, 2 comma 4, 2 comma 5. So now for 3, it is 3 comma 1, 3 comma 2, 3 comma 4, 3 comma 5. 4 comma 1, 4 comma 2, 4 comma 3, 4 comma 5. Similarly, 5 comma 1, 5 comma 2, 5 comma 3, and 5 comma 4. So how many are there? Can you check? 1, 4 plus 4, 8 plus 4, 12 plus 4, 16 plus 4, 20. This is our sample space. Okay. In our favorable condition, what we have is uh, 2 comma 1, 3 comma 1, 4 comma 1. These are the elements of our set. 5 comma 1 and 4 comma 2. So the numerator is number of favorable outcomes 5. The denominator is total number of outcomes 20. So when you solve this, we get 1 by 4. That's our answer, which is option. What is option? Option B, 1 comma 1 by 4. Is that clear to you? Yes or no? Yes. Let me give another example. Assuming 3 coins are tossed. 3 coins are tossed. Find the probability that at least 2 heads are turned up. At least we get 2 heads. First, when you toss 3 coins, what are the outcomes? Let's analyze that. We'll write the sample space. All are head, right? And then 2 heads, 1 tail. This can happen in 3 ways. That is tail at the end, tail in the middle, and tail at the beginning. Okay, then 2 tails, 1 head. This can also happen in the similar pattern. Okay. And then finally, what we have is all are tail. So 8 outcomes are there. I want at least 2 heads. So denominator is 8, no doubt. At least 2 heads means it can be 2 heads as well as more than 2 heads, but it is not going to be 1 head. So these are ruled out, and 0 head is also ruled out. So what is the numerator? 1, 2, 3, 4, which is 4. Okay. Is there any other way to solve this? Is yes. So if you say at least two head, three coins are tossed, so it has to be 3C2 or 3C3. Denominator is same, 2 power 3. Okay, so that is 8. In the numerator, 3C3 is 3C2 is 3, 3C3 is 1. Because I know NCN is equal to 1, NC1 is equal to N, which is NCN minus 1. So I can write as 3C1 and 3C3 if you want. That is 3 plus 1 by 8, which is also 4 by 8. And further simplification, it becomes 1 by 8, 1 by 2. So the chance is exactly half, that is 50%. Now, can we give one more example like this? Yes. So 5 coins are tossed. What is the probability of getting at most 3 heads? Now, what is the meaning of at most? At most means there is also a name. Also, we can say not more than. It can also, that is not more than, meaning it has to be less than or equal to. Okay, or maximum, all are same. So the question is simply probability of getting at most 3 heads, means less than or equal to 3 heads. So as we have 5 coins, so we can start with no heads, 1 head, 2 head, and then 3 heads, right? Not more than that. What about denominator? Denominator is 2 power 5, that is fixed as 32. The numerator is 5C0, which is 1, right? 5C0 is 1, 5C1 is 5, 5C2 is how much? 10. So you need to remember them. We don't have to calculate this every single time. You can remember them, but not by adding them again. By solving multiple times, you will remember the values. 5C2 is 20. 5C3 is also equal to 5C2 because NCR is equal to NC N minus R. 5C2 is equal to 5C3 is equal to 5C 5 minus 3. Simple. That is also 10. Now what we get is denominator 32. The numerator is 26. Can you see that? Yes. 10 plus 10, 20. 20 plus 5 plus 1, 26, which is 13 by 16. Okay, that is the probability. If I say at least 2 heads, at least 2 heads is probability of getting 2 heads, which involves 5C2 plus 5C3 plus 5C4 plus 5C5 divided by 32. You can also go for the shortcut 1 minus opposite of that P of less than 2 heads, which is 1 minus 5C0 plus 5C1 divided by 32. Shall we verify this shortcut? The numerator will become here 5C3 is 10, 5C2 is also 10, 5C4 is 5, 5C5 is 1 divided by 32, which is again 26 by 32, okay, which is 13 by 16. Same way here, 1 minus 5C0 is 1, 5C5 is 1, 5 divided by 32, which is how much we get? 1 plus 6 by 16, which is 1 minus, right? 1 minus 3 by 16, which is again 13 by 16. Yes, both are right. That means whichever is convenient for you, you can use it, but you should be logically right in the conversion. Okay? Yes. That's all about basics of probability.